All right, in context of talking about atoms and covalent bonds and how binary molecular compounds are formed from their elements, it's worth having a slight discussion or brief discussion about the strengths of covalent bonds. A bond is formed when you combine two individual atoms and you bring them together, and it's a low energy state, and so energy is released when the molecule is formed, such as the hydrogen molecule. And so the strength of the bond is reflected in how much energy it takes, how much, in a bond association energy context, how much energy it takes for the bond to be broken. So it's exactly the opposite of the amount of the energy released when you form the bond. It takes that much energy. Money is a currency for molecules, or energy is the currency for molecules. How much energy is going to be required to break a bond? Boy, this thing is really touchy today. I apologize for that. Wow, I can't win. Okay. So in any case, there's always energy required to break a bond. Always required. Bond energy is released in making a bond, but it requires energy to break a bond. So how much does it take, and what do we need to know about these numbers? Well, there's a chart of values in your textbook which you really don't want to focus in gigantic detail on, but there's some things that are relevant to note. There's a bunch of single bonds that are noted, and you can see that the values never have more than 3 digits. And then there's some multiple covalent bonds down at the bottom, like double bond between carbon, triple bond between carbon, double bond between carbon and oxygen, to double bond between 2 oxygens. All of those are options of things that can be measured and described in terms of their relative energies. Well, you can tell if you look at this that single bonds are going to be weaker than a double bond. So here's the carbon-carbon single bond, and here's the carbon-carbon double bond. And it's going to take a lot more energy to break a double bond, and even more energy yet to break a triple bond. So that's the first thing to think about. A triple bond, double bond, and single bond can be equated or related to analogize with rubber bands. So if you have one rubber band holding 2 atoms together, that's like a single bond. If you have 2 rubber bands holding them together, it's twice as strong, much more difficult to break it, and so that's like 2 rubber bands between things. And then if you put 3 rubber bands between something, that's like having a triple bond. So the more bonds, the stronger the bond, and in fact shorter too, but how much energy it will take to break them apart. So there's another thing to note, and that is that those values provided are average covalent bond strengths. So carbon-carbon bonds are going to be just a little bit different in energies. They're all in the category of kilojoules per mole here, but they're going to be similar for different contexts, but not necessarily exactly the same. So the values in that table are, in fact, averages. Averages for how much it would take to break that bond. And so the values that we see in that chart are generally 350 to 400. Let's flip back and look at it. There aren't too many that are above that. Well, there's a couple, but 350 to 400 in a general sense. Some are lower, some are higher, but that's just a ballpark estimate of things to realize. That's all I'm going to say about the strengths of covalent bonds for today.